Audio 3 on electrodynamics. So the topic we're doing today is using the principle of electromagnetic induction to explain how a generator works. The working function of a generator is based on Faraday's law of electromagnetic induction, studied in grade 11. Faraday's law of electromagnetic induction states that the magnitude of the induced EMF across the ends of a conductor is directly proportional to the rate of change of magnetic flux linkage with the conductor. Let me also remind you about the formula for calculating the induced EMF and magnetic flux. The induced EMF, small letter E, is equal to minus N indicating the number of turns or windings in the coil, multiplied by change in magnetic flux, then divide by delta T, change in time. Then if you are calculating the magnetic flux is equal to BA cosine theta. Magnetic flux equals to B indicating the flux density, multiplied by A, area through which it is flowing, and cosine theta, angle between the flux density or the magnetic field and the line drawn perpendicular to the face of the coil. So it was taught in grade 11. Then how a rectangular coil rotates. The range is from 0 degrees to 360 degrees. Rotation depends on how the magnetic flux is accumulated in the form of cosine graph. Then the rectangular coil is moving from north to south in the form of sine graph. It means the movement of the induced current and EMF is influenced by the sine graph. So I'll say in summary, I'll say that the magnetic flux through the coil is determined by cosine theta. The induced EMF and current are determined by sine graph. Then looking at the graph, at cosine 0 degrees is equal to 1. Cosine 180 degrees is equal to minus 1. Cosine at 360 degrees is equal to 1. Then the coil at 0 degrees, at 180 degrees, at 360 degrees, in those angles is perpendicular. So it means the magnetic flux is more concentrated. The flux passing through the coil now is at its maximum. Then looking at cosine 90 degrees is equal to 0. Cosine 270 degrees is equal to 0. The coil at 90 degrees and 270 degrees, the magnetic flux has decreased drastically to 0. Note, a magnetic flux from 0 degrees to 90 degrees is decreasing drastically to 0. Then from 90 degrees to 180 degrees is increasing to minus 1 because it's moving downwards. Then from 180 degrees to 270 degrees is decreasing to 0. Then from 270 degrees to 360 degrees is increasing to 1. Then if you are considering the induced EMF and current, so we say that the induced EMF and current is determined by the sine graph. Sine 0 degrees is equal to 0. Sine 180 degrees is equal to 0. Sine 360 degrees is equal to 0. There is no significant change in the induced current. The induced current and EMF is 0. Then looking at sine 90 degrees is equal to 1. Sine 270 degrees is equal to 1. The induced current and EMF are at maximum. Note, induced EMF and current from 0 degrees to 90 degrees are increasing drastically to 1. Then from 90 degrees to 180 degrees is decreasing. Then from 180 degrees to 270 degrees is increasing. Then from 270 degrees to 360 degrees, so they are decreasing. Therefore, the induced EMF is directly proportional to the speed at which the coil rotates in the magnetic field. So it's also proportional to the strength of the external magnetic field. It's also proportional to the cross-sectional area of the coil. Then is also proportional to the number of turns or loops in the coil. Revise the definition of Faraday's law of electromagnetic induction. Practice the problems with regard to the two formula. Write your own notes making sense of the magnetic flux and the induced current and EMF. Thank you for today.